Hello everyone, now let's talk about torsional deformation. Now you might be thinking to yourself, well, we've already done that. We did this earlier. And you're correct. But what we looked at before was saying like, okay, how do we get the shear stress based on how it's deforming? Or how do we get the shear strain based on how it's deforming? We didn't really care about the angle. However, in some cases, an important aspect of when a material has failed to meet its function, when a material fails, is when it fails to meet its function, not when it fails as when it breaks. Like, for example, let's look at this doorknob right here. Now, imagine that you could spin that doorknob 360 degrees. Well, that's not too crazy, but what I mean here is that it's not actually turning the locking mechanism. It's just that the doorknob is so flexible that its shaft can spin and 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 spin until finally after like 15 spins, it gets tight enough that you can actually turn the doorknob. It's like the doorknob handle is made of rope and you're having to continuously twist it tighter and tighter and tighter until finally it's tight enough that there's enough force in there to turn the locking mechanism. That doesn't make any sense. That means it has failed. Now we have better reasons for this in other places, but just for now, this is a kind of a good idea of where we're going. This is an exaggeration, but it's a good idea of where we're going. So at the torques we're applying, we don't want the doorknob to easily deform, and we don't want that deformation because it will mess up how it's supposed to do things. It's supposed to move the mechanism or just stay there, one or the other. Okay, now we had our shear stress equation from earlier, and we can actually use this to then determine an equation for the angle of twist. Now, I'm not going to do the full derivation here, but what we get at the end is that the change in angle of twist with some specific length is going to be our torque over our polar moment inertia over our shear modulus. Or if we integrate, because our torque is constant, and our cross-section isn't changing, we can get this nice simple equation, which is our torque twist equation. However, this is only for torsional members that are homogenous. It means they've got a constant shear modulus, prismatic, which is a constant polar moment inertia or a constant radius, and a constant internal torque. Otherwise, we're going to have to integrate, or we're going to have to do this if we have multiple sections. We might have several sections all attached to one another, and that's okay. You can still solve that using this torque twist equation. But once again, if you don't know where this comes from, please check your book for a full derivation. I just don't want to go ahead and do all the steps here. Now let's talk about some sign conventions. All of our sign conventions follow the right hand rule. So go ahead and grab your hand and wrap your fingers around this line. And what you'll see is that your thumb is pointing, make sure I'm drawing this correctly, I am, out that way if you try to wrap your fingers around that axis. So if you wrap your fingers around the positive x-axis, your thumb points in the positive direction. Or better yet, if your thumb is pointing along the positive x-axis, then your fingers wrap around in the direction that is the positive change in angle. Okay? And that is positive for either side. So a positive torque will have an opposite rotation on either side, still based on my right hand rule. Okay, still based on my right hand rule. So it also tells me that for my angle of twist, while down is positive on this side, up, but it's hard to show, would be positive on that side. It's going to be based on what side you're looking at too. But that right hand rule will help you get through it. Now, the thing about this is that a positive angle of twist is in the same direction as a positive torque. So if you know how to do the torque properly, you should know how to do the angle of twist properly. Okay, I think that's everything. It is. So we'll stop here. And next time we're going to jump into some examples. So thank you for listening. And I'll see you all next time. Bye-bye.